राइट। चलिए ज़्यादा बातें ना करें कॉन्सेप्ट्स की, बट कैपेसिटर्स की दो बेसिक कॉन्सेप्ट्स आपको क्विकली सीख जाओ, द सीरीज कॉम्बिनेशंस ऑफ कैपेसिटर्स एंड पैरेलल कॉम्बिनेशन ऑफ कैपेसिटर्स। देन हम थोड़ा रेजिस्टर्स की सीरीज कॉम्बिनेशन और पैरेलल कॉम्बिनेशन के बारे में क्विकली कवर कर रहे हैं, ठीक है। देखो कैपेसिटर्स, आप बेसिक प्रिंसिपल ऑफ कैपेसिटर्स पढ़ रखे हैं, सब कुछ मैं यहाँ नहीं क्लास लेने वाला नहीं हूँ, मैं बताया था मेरे पिछले लेसन्स में, बट आपको जहाँ जहाँ कन्फ्यूजन आ सकता है, जहाँ जहाँ क्लैरिटी की ज़रूरत है, वो सब चीज़ों के लिए मैं हिटन करूँगा, ठीक है। तो आप ये देखो कि सीरीज कॉम्बिनेशन ऑफ कैपेसिटर्स कैसे कनेक्टेड हुआ है। बेसिकली देयर इज वन बैटरी connected to three capacitors C1, C2 and C3, right? The terminals are marked here positive, negative, positive, negative, positive, negative for the capacitors C1, C2 and C3, and the positive terminal of the battery is connected to the positive of the capacitors C1's first terminal and the negative terminal is ending up with capacitor C3's second terminal, right? This is how one after the other. Series means what? One after the other. The connections has been happened. Series connections of the capacitors is done. You can see it. Now charging of capacitor, discharging of capacitor, basic principle of capacitors, everything has been told by your teachers as well as your competitive teachers in the classroom scenario, right? अब देखो इसमें जो potential developed होगा because of the main potential source which is being supplied as V. The charge in the capacitor C1, the charge in the capacitor C2 and the charge in the capacitor C3, as the same charge is is in series. The Q charge and the Q charge. Basically the same charge is being developed. That is why you are getting Q is same here, C1, C2 and C3 will be getting the same charges in their capacitances. That means the potential which will be developed here in the first capacitor will be V1, but the second capacitor will be V2 and the third capacitor will be V3, right? But as you know the conservation rules, the potential which is supplied from the sources will be equal to the potentials developed across the capacitors. That means the overall potential V which we are supplying from the sources should be equal to V1 plus V2 plus V3. That is why if you write in the form of the V1 in the form of the charge and the capacitance, V2 in the form of charge and the capacitance, V3 in the form of charge and the capacitance, and V in the form of charge and the capacitance. The charge per unit potential is your capacitance. The charge per unit potential is the capacitance. This is the basic formula you use for the. So what is the V concept you are getting here? What is V from here? You will be getting V is Q upon C. V is Q upon C. So V is Q upon C. That means this V overall potential can be the overall charge upon the overall capacity of the capacitors connected in series. Right? So this V can be written as Q upon C and V1 can be written as Q upon C1. V2 can be written as Q upon C2, V3 can be written as Q upon C3. That is why if you see the charge same is the charge, then you can equate overall from the left side and the right side, and you will get easily the formula for the equivalent capacitance of the capacitor when connected in series. So 1 upon C1 plus 1 upon C2 plus 1 upon C3 should be 1 upon C equivalent. What do you say? When the capacitors are connected in series, when the capacitors are connected in series, then you get the inverse of the capacitances, added up together, inverse of the capacitances added up together will give you the inverse of the overall capacitance. That is why, you say 1 upon C equivalent should be 1 upon C1 plus 1 upon C2 plus 1 upon C3. Right? This is how you get for the series combination of capacitors. And this one, let me jump toward the resistors. Okay? In resistors, you can see the formula for the parallel combination of resistors. The formula for parallel combination of resistors holds the same type, right? That 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. When you are talking about three cases of resistors connected in parallel, okay? That is how you need not to confuse yourself when you are applying the capacitors in series and you are saying 1 upon C equivalent is 1 upon C1 plus 1 upon C2 plus 1 upon C3. The same will be utilized in parallel combination of the resistors. That is, your series cases will be like the parallel combination of the resistors, and the parallel cases of the capacitors will be like the series combination of the resistors. See, when parallel combination of the capacitors you are taking, what is the difference between the series and the parallel? Look at here. The parallel combination we have done for the capacitor C1, C2 and C3. How are they connected? You can see as the same potential of your source. The positive is connecting your first terminals of your capacitor C1, C2 and C3. The second terminals of the capacitors C1, C2 and C3 are connected to the negative terminal of the source potential. Got it? Clear? So, you are getting now charges will not be same. Now, charges will be different because potential is same. And capacitance is C1, C2 and C3. Same potential having different capacitances will generate different charges. Right? Getting the formula I have. So Q1, Q2 and Q3 will be the charges across the capacitors C1, C2 and C3. So your overall charge which you will be getting out from the source will be Q, which should be equal to Q1 plus Q2 plus Q3. That means using the formulas of what is Q, C into V. What is your Q1? C1 into V. What will be your Q2? C2 into V. Q3 will be C3 V. Same way, equate now. As the potential is same, cancel out from left hand side and right hand side and you get C equivalent. C equivalent should be C1 plus C2 plus C3. Got it? Clear? That means when the capacitors are connected in parallel, the effective capacitance or the overall capacitance of the capacitors is the sum total of the individual capacitances of the capacitors. Am I clear? Should we move? So, when you are connecting the resistors in series, look at here. When the resistors R1, R2 and R3 are connected in series, what is there? You see, the source potential is connected to R1, R2 and R3. What is same here as they are connected in series? The current I is flowing through R1, R2 and R3 in the same way, same quantity. So, same current is flowing through R1. That means I into R1 will be your V1, I into R2 will be your V2, I into R3 will be your V3. That means the V, the supplied potential, should be V1 plus V2 plus V3. That means V is V1 plus V2 plus V3, or I into R1 plus I into R2 plus I into R3. Clear? So I into R is I common with R1 plus R2 plus R3, and you say R effective is R1 plus R2 plus R3. That means when the resistors are connected in series, you are using the formula for the effective resistance as the sum of the individual resistances. Clear? And when you are connecting the resistors in parallel, look at here the connection clearly. The source is being connected to 3 resistors in parallel. What is here same? The potential is same, because the terminals of the first one, second one and the third one are connected to the same terminal. So potential across V1, R1, R2 and R3 are same only. What will be different here? As resistance is different and same potential is being applied or thrusted, what will happen is I1, I2 and I3 currents will be developed or generated across the resistors R1, R2 and R3. Means what? Means what? You are getting your I1, R1 will be the potential, I2, R2 will be the potential, and I3, R3 will be the potential, which is I into the effective resistance R. So when you are talking about I, what is I? That is V upon the effective resistance. So what is I1? You can see as V is same here, V is same here, you will be getting V upon R1, V upon R2 and V upon R3 will be your I1, I2 and I3. But your Kirchhoff's first law will be telling you that I current entering to the terminal and I1, I2 and I3 currents leaving out from the terminal. That means I is equal to I1 plus I2 plus I3. So equating, you will be getting for I as V upon R equivalent, I1 as V upon R1, V upon R2, V upon R3, I1, I2 and I3. So equating left hand side and right hand side, you will be getting clearly 1 upon R equivalent should be equal to 1 upon R plus 1 upon R2 plus 1 upon R3. Reciprocal, right? The reciprocal of the resistances added up together.